how can we possibly using the LangChain framework to much simplify and streamline any large language model based application development. So what LangChain can do for you? Basically, a lot of the benefit. For example, it can help you to build a universal document processor, which I'm going to demo in a minute. Also, it can automate any embedding vector creation, also the creation of the knowledge, the database, and also the information retrieval process. It can seamlessly integrate with any private or open source large language models, and then allow you to using a whole pipeline to fast build any large language model generated AI app. So today I will do a hands-on notebook to show all these kind of the benefits and features, plus a quick demo of a Q&A bot app using the LangChain, open source large language models, and streaming it. Let's start. So actually, by using the LangChain, we can just like to the automate all these kind of data collection, document loading, the text chunking, split, vector database, the building, retrieval, and the pipeline, and so on. First of all, you need to actually to set up the LangChains and the packages. So this is all the dependency you have to specify. And then the first part, we are going to building some universal file processor. So actually the LangChain have the built-in support for a lot of the document and file types already, such like the PDF, TXT, CSV, JSON, HTML, Markdown. And now I'm also going to build my own, the pinpoint and the document, one more document, the file loader on top of it. So this is the utility function I define. Also, I'm using some open source libraries, Python libraries, to loading and convert the pinpoint document and the Word document into the text document. So this is all the utility function I define. So I won't go to the details, and I will share the code, and you can always like review offline. So, and then finally, this is the utility function, any file loader. So you can see we so far supporting like the 8 different types of the file types accommodated, and it's also be configured in this supported file types file. Of course, this is give me the scalability. So anytime if I want to add the more, the file format support, I can just specify higher and then adding some utility functions to support it, comfortably afterwards. So yeah, once we define this, and also we actually make some like the abnormal handling if with any file is actually not supported yet, we are actually to throw some exceptions and skip the processing this kind of data. Okay, right? Okay, let's move to the second part. Now here I can iteratively to get all the files in a folder and all the is subfolders in Python. So this is some code. For example, there's some like the folders I store some like sample data here. Okay, so here you can see a lot of the sample dummy data, like the ethics or artificial intelligence, Wikipedia, the wiki ChatGPT TXT file, and one Word document talking about the AutoGDP, and the pinpoint talking about the PDF text extraction tools and so on. So yeah, a lot of document. I'm going to actually let the the LangChain to actually automatically to loading and process all these kind of different the file types now. Okay, so. And you can see after I execute code, all the the file has been nicely loaded and processed. Okay, and if some like for example, spreadsheet file has not yet been supported, it will be set not supported format, and then we'll skip. Okay, right? Okay, then after the loading all the the document, then you have to do the text chunking. Basically to split a whole document into a multiple smaller text chunks ready to generate the embedding vector for each text chunk. So this some like hyperparameters chunk size define like the how many characters per text chunk you need, and also the chunk overlapping. So this is very useful because, for example, if the whole paragraph has been divided into like the two separate chunks, however, it will actually make some like the context separate. So in this way, you can just using the overlapping to keep the context, the for for your the original like the text input. Okay. For example, now I will process like the all these kind of different document, and we get like 222 chunks. Okay. Then in the second part, vectorize text to create the knowledge database for semantic search. So basically, we can load in our source data as we already done. Then we call the embedding in language models to actually to vectorize all the text chunks into the embedding vectors and store all these kind of the vectors into our the embedding vector knowledge database. So if any new user query is coming, and we also like to generate the embedding vector for this new query, and then compare with all the record into the knowledge database to see which is the most similar one, and retrieve that like the top similar record from the database. That is like an idea. So basically, you can using the LangChain to specify the embedding model. Here we're using the like the E5, the embedding model. You can also using any other embedding models such as like open source instruct models or like the proprietary the add models and so on from OpenAI. Then second step, we create the embedding vector database to store the knowledge embedding vectors. So there are many the great the open source free vector database options available, which can the entirely run on your local machine, such like the Chroma, Facebook's FAISS, Lens, and so on. So this is some like the instructions how to install the Chroma database and also some the bug shooting. Yeah, and then you can just like to supply a persistent directory to store the embedding on disk, and then specify embedding model you're using, and then creating the text embedding vectors per text chunk, and store all of them into the vector database. After you've done that, you can save the database to the disk, and you can reload it back and for the the retrieval purpose. And then in the third step, we can do the semantic search, which is like the text similarity search. So for example, I give some like the sample query. What is allowance for dinner meal for business travel? So then you call this vector database. So basically there are three different options. You can search by using the similarity search command. So you can retrieve some similar the relevant document and the records. You can also use the second option, which is like using the similarity search by the vector. So this is another option, gets the similar result. Also, you can using the third option, search by the text using the retrieval option. So here you can specify the how many top the most similar the records you want to retrieve from the vector database. The default is the top 4. You can always fine tune it to like the smaller or larger numbers, like 3 or top 5 or top 6 afterwards. So now actually we actually do this, and you can go to all these embedding vectors. Okay. So in the third part, we can like using the LangChain to streamline the whole retrieval pipeline. So much simplifies the end-to-end information retrieval and the knowledge search pipeline development. Okay. So, and you can using the LangChain to specify any computation model you want using. Here we're using the fast-chat T5 model, and then we create a retrieval chain to answer the question with domain knowledge. Here, this is just like a simple like the line code. You can create the question answering information retrieval chain. Then you can just use it. For example, my query sample, what is the maximum allowance for lunch meal, and you'll get the result. So then you can just like define some utility functions to actually to clean up the output. So here, this is a very clean, the output, like the answer is 10 pounds, maximum allowance for lunch, and then also give you the reference source document, the language model is using. So in summary, you can see the LangChain and the have the pros cons compared with the building from scratch approach. The advantage of the LangChain is it can simplify and streamline any language model-based application development, code reusability, and scalable. And also its disadvantages is hide some underlying, the implementation details and low-level APIs. So we lose a bit like the flexibility and the transparency as it look like some black box. Whereas the building from scratch approach, that can give you the full control, full flexibility, and the transparency. The code highly customizable. You can do whatever you want. The cons is actually you need more effort, and the code scalability is a concern. Okay, that is the introduction, and then we are going to the live demo. It's my demo Streamlit app. So basically here you can drag and drop any file to here, or the supporting many file formats here. So you can either drop any like a single file or like the multiple file here. And because the Streamlit have some limitation, it cannot give you any like the folder picker. So I actually group and compress multiple files into a zip file, and I'm going to drag and drop here for some quick test. Let's do it. So this is some like the all out of the document and the files or different formats. Okay, it's starting to processing the multiple documents, and then to generate some embedding vectors and also the embedding vector knowledge database. Okay, behind the scene. So you can see at the background it's starting working. Okay, so generate all these kind of the text chunks. Now we got more than 200 chunks generated. Okay, so it only takes like the large language models 10 seconds, to actually to do the document loading and chunking. Okay, that's it. Okay, then we can just like ask our the Q&A bot any question. Okay, what is the difference between AutoGPT and ChatGPT? Okay, just ask any question. Okay, behind the scene, the stream app will call the LangChain Q&A, the larger models to actually answer this question. Okay. Okay, still working. Okay. Then start to call the large language models to generate a response to the user query. Okay. Yeah, okay. After waiting 22 seconds, we get the response from the large models. So it said AutoGPT is an AI agent that assigns itself new objectives to work on, with ML reaching the great goal without the mandatory need for human input, while ChatGPT is a large language model-based chatbot developed by OpenAI and launched on November. Notable for enable users to refine the steer a conversation towards a desired length, format, style, level of detail, languages. Okay, quite nice, like the the summary to answer my question. So you can also like the LangChain indicated what is the reference sources for the larger model to actually give this answer. So basically they're using the AutoGPT document as well like ChatGPT wiki document. Nice. So this is just give you a quick demo how possibly we can using the potential of the LangChain to streamline and accelerating any development of the large language model based application. and hopefully you learn something today. Okay, to this channel to keep updated on the latest AI, machine learning, generative AI trends, and also download a copy of this slide deck and also the hands-on notebook, so you can just to study and explore offline by yourself. Also, you can to get all these kind of free data science notebooks and resources. Thank you, everybody. See you next time.